So today we're talking about sums of radicals, and we're going to simplify each of these so that way we can combine like terms. So going back to our previous lesson, we need to make sure we do the prime factorization of each of these radicands so that we can simplify those. So square root of 50 becomes 2 times 25, or 25 times 2. And then square root of 245 becomes 49 times 5. And then 125 becomes 25 times 5. So then you can take the square root of 25, which is 5. So we have 5 times 2 square root of 2. And then we can take the square root of 49, which is 7. And then we have the 5 still under the radical. And then we can take the square root of 25, which is 5. And we're just multiplying what's left over. And then we still have that 5 under the radical. So now let's just simplify the coefficients, and then we'll combine like terms. So 5 times 2 is 10. The 7 square root of 5 stays the same, and then 5 times 3 is 15. Now we can look and see if we have any like terms. How many square roots of 2 do we have? Well, we only have this 10 times square root of 2, so we can't simplify that. But we have these square roots of 5 that we can combine together. We're going to combine them just like we do when we have variables. Okay, so negative 7 times 15, or plus 15 gives you 8. And that's as simplified as it can get. So we have 10 square root of 2 plus 8. So this time, instead of the square root, we have cube root. So we want to simplify these so that we would have perfect cubes times something else inside. Well, we can't simplify the 9 because that just breaks down into 3 times 3, and that's just a perfect square. The 81 we can simplify to 27 and 3. So here, let's write down our 2 times the cube root of 9. We can't change that. But we can change this to the cube root of 27 times 3. And then here we're going to do something a little bit different. If you go back to our previous lesson, when we had a fraction inside the radical, we wanted to multiply by something that was going to get us to simplify, or going to allow us to simplify. Well, we have 1, 3 here, so we need 2 more if we multiply to get it to be a perfect cube. So we can multiply by 3 squared, and then whatever we do in the denominator, we have to do in the numerator. So we're not changing the value because we're multiplying really by 1. So then that becomes minus 2 cube root of 3 squared is 9, and then 3 times 3 squared is 27. All right, so then again here this just stays the same. But then we can take our cube root of 27, which is 3. And then here we can take the cube root of this 27. So it becomes 1/3, because remember it's in the denominator. So you have 1/3 times the 2 cube root of 9. Okay? Let's just slide this up a little bit. And so now we actually have 2 terms that have the cube root of 9. But let's simplify this one first before we add them. So we have 2 cube root of 9 plus 3 cube root of 3. And then when we multiply these, it becomes 2/3 cube root of 9. So now we have these like terms, and 2 minus 2/3 is going to give us, okay, 2 minus 2/3 is going to give us 4/3. And that's your answer. All right, so now let's take a look at example number 3. Now we're getting into distributing, so we're multiplying our radicals, okay? And it's very similar to when we multiply using variables. We're going to use our distributive property here, and we're going to multiply. Now you can only multiply whole numbers with whole numbers, or coefficients with coefficients, really, not whole numbers, but coefficients with coefficients, and then radicals with radicals. And when you're multiplying radicals, they have to be the same kind, like they both have to be square roots or cube roots, for now. All right, so when we multiply this, we're going to take the -4 and multiply that by the 3. Then for these radicals, we can multiply, inside the radical, we can multiply 6 times 2. Then we have distributed to the second term, so we have -4 times -5. So we have -4 times -5, and then we're multiplying inside the radical, so 6 times 3 goes in that radical. And then we just still have that guy left over. So there he is. All right, so now we want to simplify inside the radical. We're going to simplify this as well. So we have -12 square root of 12. We have 20 square root of 18. And then 5 square root of 48. Now we want to look and see how those can simplify or break down. So we can say, well, this is 4 times 3. And 18 is 9 times 2. So we're looking for the biggest perfect square that is a factor of those numbers inside the radicands. All right, and then we have 5, and then square root of 16 times 3. So now we can take the square root of 4, which becomes a 2. So we have 2 times -12, square root of 3. Take the square root of 9, which is 3, times 20, square root of 2. And then take the square root of 16, which is 4, times 5, square root of 3. Now we're just going to simplify. Let's bring that up a little bit. 2 times -20, or -12 is 20, -24. 3 times 20 is 60. And 4 times 5 is 20. And then we have square root of 3 here, square root of 3 there, so we combine like terms. -24 plus 20 is -4. So you can write 60 plus, not plus, it's going to be 60 times the square root of 2. Okay? It's okay to make mistakes as long as you see them. All right, so 60 square root of 2, and then we're going to combine these, and it was -4 square root of 3. And that is your answer. Now let's take a look at example number 4. When we have fractions here, we can break them apart. Because this is just one term on the denominator, you can separate that numerator. So we can say 3 square root of 40 over the square root of 8 plus 2 square root of 24 over the square root of 8, and then minus square root of 5. So now what you can do is, because these are both under radicals, you can divide those. So that's really like saying this. Oh, be careful with that. That kind of looked like a cube root. We don't want to do that. So it's 3 times the square root of 40 over 8. That's 40, not 48. All right, and then this can become 2 times the square root of 24 over 8, and then minus the square root of 5. So what's 40 over 8? 5. And then 24 divided by 8 is 3. And then we have these square roots of 5 that can be combined. So 3 minus 1 gives us 2. Let's move that up just a little bit. 3 minus 1 is 2. Oh, that's a 3. And that is your answer.